Hello, this is a video about the sieve of Eratosthenes, and here in this video we are going to look at how are we going to find out the prime numbers. Now this method, the sieve of Eratosthenes, is used to find out the prime numbers from 1 to 100 by cancelling out all the multiples of the numbers that we start with. So let us see how can we learn about the sieve of Eratosthenes, and also we are going to learn about an easy approach how we can find out all the prime numbers. In order to start with this, let us take the numbers from 1 to 100. So we have a list of numbers from 1 to 100 here. Now the prime numbers are those numbers which are having only two factors. So the number 1 can be excluded here. So the number 1 cannot be a prime number and cannot be a composite number as well. So we can eliminate the number 1 here, and we are going to find out all the prime numbers from 2 to 100. In order to find out, let us first learn this method, after which I'll explain the easier way in order to find out all the prime numbers from 2 to 100. Now we'll start with the number 2. So this is the first number. So we'll do a circle of this number 2, after which we are going to cancel out all the multiples of 2. Now the multiples of 2 are 4, 6, 8, 10 and so on. So we have so many numbers are there, and we'll be able to cancel out all the numbers. This is a long process. We'll be able to notice that we can cancel out all the numbers here with the second column and the fourth column, sixth, eighth column, as well as the 10th column. So this is a way to find out that these numbers that I have crossed out are all composite numbers. They all cannot be prime numbers. Next, after 2 we have the number 3, so we can circle the number 3 and cancel out all the multiples of 3. So 3 times 2 is 6, we have already cancelled it out. So 3 times 3 is 9, we can cancel it out here. 3 times 4 is 12, 3 times 5 is 15, so we can cancel it. 6 is 18, 3 times 7 will be 21 and so on. So you will be able to cancel out all the multiples of 3. And we can also find out that so many of these numbers are not or prime numbers. So these numbers that we are striking out are also composite numbers. So we have some more numbers here, and yes, I have cancelled out all the multiples of 3. Now we see that the next number is 4, which is striked out because it is a composite number, because it is a multiple of 2. And hence the next number is 5, so we are going to cancel out all the multiples of 5. We have to circle 5 and then we'll cancel out all the multiples of 5. So 5 times 2 is 10, 5 times 3 is 15, 4 is 20 and 5 times 5 is 25, which we can cancel out. And we'll be able to notice that this vertical line, we have all the numbers which are multiples of 5, and here on the 10th column we see all of them are multiples of 5 as well. We have already cancelled them here. So we are done with all the multiples of 5, and we see that the number 7 we need to circle the number 7 and cancel out all the multiples of 7 wherever we can find out. Now I can see that the first multiple of 7 which is not striked out is the number 49, so we can strike out 49. You can verify whether the other multiples of 7 are striked out already. And going on, we have the number 77 we have, and then we have 84 which is there, and 91 which is also a multiple of 7. And then now we are done with all the multiples that has been striked out. So the last number is 100. Square root of 100 is equal to 10, because when we multiply two numbers to get 100, one of the numbers will be greater than the square root, one of the numbers will be less than the square root, or both the numbers will be equal to the square root. So less than 10, we can find out that all the prime numbers are 2, 3, 5 and 7. So when we take the multiples of 11, we can find out that all the multiples of 11 are already cancelled out. You can verify for yourself. So all the prime numbers are visible now. So what the numbers which are not striked off can be circled. So these are the numbers which are prime numbers, and you will be able to notice that there are 25 prime numbers. So we have 25 prime numbers. The numbers that I am circling out, you will be able to get these prime numbers here. The next prime number is 61. We have 67, and then we have 71, 73, 79, 83, 89, and 97. So let us count the number of numbers which are circled. There will be exactly 25. Okay, so this is how we are able to find out all the prime numbers by using the method called as the sieve of Eratosthenes. Now we are going to find out an easy approach to find out all the prime numbers. We'll start with a new table of the numbers from 1 to 100. Let us see how can we find out all the prime numbers. Now the same method that we need to start, the number 1 is already eliminated because it is neither a prime number nor a composite number. We'll start with the number 2, and we know we need to cancel out all the multiples of 2. So what I'm going to do, I'm just going to cancel all of the multiples of 2 vertically. So we can see that all these alternate columns form even numbers and they can be cancelled out. And next we can see that the multiples of 5 also we have vertically we can see that the numbers are present, so we can circle the number 5 and then cancel out all the multiples of 5. Now more than half of the board has been cancelled out, and those numbers cannot be prime numbers other than the numbers which are circled. Now we know that the number 3 is a prime number, so circling 3, after which let us see the numbers which are to the diagonal of 3 towards the left are multiples of 3. So we can cancel out the numbers through the diagonal. Once this diagonal reaches to the end left, on the same line we move towards the right side end and continue striking the numbers till the numbers reaches to the bottom level. So I have cancelled all the multiples of 3. Now here the numbers 21, 39, 57 and 93 are cancelled for the first time, indicating that these are multiples of 3 and these numbers are composite numbers. Now we have got a multiple of 3 on the same line, on the first line, which is 6. Now starting with 6, we'll just do the same pattern by crossing out the diagonal towards the left side till 51, and now 51 is there till the end. We need to travel because 51 is on the left end of a row. The same row we need to move towards the right side end and start with 60 and then move on till 96, and this is the last row. So when the last row comes, we can stop. Starting with 9, which is also a multiple of 3, we'll follow the same pattern. We'll start cancelling the numbers and we need to follow the diagonal very clearly, and this leads to the number 81 towards the left, and starting on the same line towards the right end we have got the number 90. Starting from 90 we end with 99, and when we observe this as well as the previous method, you can find out that almost all of them has been cancelled, but still there are some numbers. And let us see what are the numbers. Now we can remember that there are only 3 numbers present here which are composite. Let us see how can we remember. Now we know that the number 7 is a prime number, so we'll circle 7. Since 7 is a prime number, a number formed by double 7 is a composite number. So the number 77 we can cancel out. So the first number that we have cancelled is 77. So I have cancelled out 77 here. And what is the second number is just multiply the two sevens here. 7 multiplied by 7. We have the number 49, which also can be cancelled out. Let us write the number 49 here. And the number 4 plus 9 will be 13. I'll take the sum of the digits of this number 49, which we have 13, and this number 13 multiplied by 7 gives us the number 91. So we'll cancel 91 as well. Now I have cancelled 3 numbers, and all the numbers which are not cancelled yet are prime numbers. So let us circle the numbers and let us count that we have 25 prime numbers from 1 to 100. So these numbers are till 50, and next we have got the number 53 followed by 59, and in the line of 60 we have 61 and 67. In the line of 70 we have got some numbers here, 71, 73 and 79, and just we have got only three more, 83, 89, and the last one is 97. And you're able to notice that these are the same numbers that I have cancelled in this method also. This is the regular method, and this method is the method that we can use easily to find out all the prime numbers from 1 to 100. The same method can be applied when we have a larger table. When we have a larger table of numbers, for example, when we have numbers from 1 to 300 or 1 to 400 or something like that, now we need to understand very clearly that the same pattern of 3 may not be applied there, because here we can do it, but when we have numbers like 1 to 11 on a row, so the multiples of 3 cannot be on a diagonal basis. So we can verify where are the multiples of 3. Now we can also observe that starting from the number 11 we have a diagonal of the number 11 which are multiples of 11, and so on. So we can find out the multiples and we can cancel them accordingly, and this way in which we'll be able to get to know all the prime numbers on the given table. So this is a very simple method to find out by using the sieve of Eratosthenes, and please share and subscribe this channel. Thank you.